Hey, it's Calc&Compile, your shortcut to simple math and computing. Ever wondered how computers process images, how 3D graphics are created, or even how Google organizes massive amounts of data? The answer lies in something powerful yet simple: matrices. In this series, we are going to learn everything you need to know about matrices, what they are, the different types, basic operations, and why they are so important in real life. By the end, you will see matrices not just as numbers inside brackets, but as a language that connects mathematics with technology. So what is a matrix? A matrix is an ordered rectangular array of number of functions, or simply a rectangular arrangement of numbers or variables into rows and columns, usually written inside brackets. These are its examples. Now, order of a matrix. A matrix having m rows and n columns is called matrix of order m cross n. An m cross m matrix is generally written as following: A11, A12, A13 up to An, A21, A22, A23 up to A2n, up to AM1, AM2, AM3 up to AMN. Here it is an since it has m rows and n columns, so it is an m cross n matrix where m and n both belong to natural numbers. Each number inside is called an element, and we usually write it as aij, where I is the row and n is the column. Next, we will talk about types of matrices. The first type, a column matrix. If a matrix only has one column, it is said to be a column matrix. General representation and its example. Next, row matrix. Similar to a column matrix, if a matrix only has one row, then it is a row matrix. General representation example. Next, square matrix. A matrix in which number of rows is equal to the number of columns is a square matrix. Thus, an m cross n matrix is said to be square matrix if m equal to n and is known as square matrix of order n. Its general representation and example. Next, diagonal matrix. A square matrix A equal to Aij m cross n is said to be diagonal if all its non-diagonal elements are 0. That is, Aij is equal to 0 when I not equal to j, and Aij is equal to some constant when I equal to j. Example, a scalar matrix. A diagonal matrix with all its diagonal elements equal is a scalar matrix. That is, Aij is equal to 0 for I not equal to j, and Aij is equal to k for I equal to j. General representation and example. Next, identity or unit matrix. A square matrix in which all diagonal elements are 1 and rest all are 0 is identity or unit matrix. That is Aij equal to 0 when I not equal to j, and Aij equal to 1 when I equal to j. Example, an identity matrix of order m is denoted by I of m. Next, zero or null matrix. A matrix is a zero or null matrix if all its elements are 0. It is denoted by O, and this is its example. Now we will talk about applications of matrices in real world. Matrices are used for computer graphics in which they used to represent 3D images as they are projected onto 2D screens and to perform transformations like scaling, rotation, and translation of objects in 3D space. Next, in data analysis, matrices are used to analyze large data sets and perform statistical calculations, such as in data analytics and scientific studies. In electric circuits, they help solve complex AC network equations by representing voltages and currents as variables in a system of linear equations. In structural analysis, they are used to calculate forces and model the stiffness of structural component. In geology, they are utilized in seismic surveys to analyze earth data. And in robotics, matrices form the basis of robot movements and automation, controlling how a robot moves in. So matrices are not just abstract math, they are the building blocks of modern technology. Thanks for watching. Don't forget to like, share, and subscribe. See you in the next one.